G'day, how you going? And welcome back to Over the Moon, the podcast where I talk to you about all things space-related, from theories of creation to new rocket designs. And today we will be talking about Voyager, the mission through our solar system and beyond. The Voyager mission was a very large-scale mission of 2 probes shot through our outer planets just before leaving our entire solar system. Voyager 1 and 2 were also the first objects to ever leave, the first man-made objects anyway, to ever leave our solar system, which is one of the things that makes this mission so interesting. The Voyager mission was launched in 1977, taking advantage of the alignment of Jupiter, Saturn, Uranus, and Neptune. Once again, Uranus is how it's pronounced. Stop it. Which can be seen at the time of recording this, from Australia anyway. The original plan for this mission was to just study the systems of Jupiter and Saturn, but the second probe, Voyager 2, travelled further on to Uranus and Neptune. After doing flybys of the outer planets of our solar system, the Voyager probes then left our solar system and are currently flying through space at around about 17 kilometers or 11 miles a second. I believe they are also the fastest moving objects known to man. While flying through space, even now they are transmitting greatly useful scientific information and doing their great mission. The Voyager probes were equipped with many instruments, most of which you can see in your beautiful image before you if you're watching me on YouTube, which would take images along with doing many other scientific processes. The first instrument on the front, the one that you can't miss, is a high-gain antenna with a 3.7 meter or 12.1 foot diameter. This antenna transmits Voyager's information back to Earth using 2 separate frequencies. These different frequencies aren't used for different distances, they are for different sciences. Like one's for engineering science, the other's for another type of science that I don't really care about because it's not the most interesting part of this mission. The second instrument is the most basic, it's the back part, and it's called the bus. It carries multiple engineering and science subsystems. It's also the main body of the entire probe. Otherwise, if it weren't there, there wouldn't be room for any of the science gadgets. The bus also has various RCS thrusters. RCS, if you didn't know, stands for Reaction Control System. They basically just make sure it's on the correct alignment. Usually they just puff out a bit of gas. I'm not sure if that's what they did here with the Voyager mission, though. The third instrument is the CRS, or Cosmic Ray System. The CRS is an instrument that looks for energetic particles in plasma. These particles can be seen in the highly radioactive fields around the planets that it is currently observing. Currently being, at the time, it could be seen. It's not currently observing any of the planets. The fourth instrument is the ISS, or Imaging Science Subsystem. The ISS is a slow-scan Vidicon camera that is a modified version of something used on past Mariner missions, being, I'm pretty sure, submarine missions. The ISS is consisted of 2 television cameras with a reel of 8 different filters. Unlike most of the scientific instruments on the Voyager probe, this camera is an autonomous, which means that it's controlled by the Flight Data System or Flight Data Subsystems, or FDS, which is an imaging parameter table on the probe's computer. The fifth instrument is the IRIS, or Infrared Interferometer, Spectrometer, and Radiometer. The IRIS is basically 3 separate instruments combined into one. The iris comprises of a complicated thermometer, which can determine the temperature of whatever it is observing, with the second sub-instrument of the iris being a device that determines the type of compounds in the atmosphere or body that it is observing. The third subsystem is a separate radiometer that measures the amounts of sunlight reflected by the atmosphere that it is currently observing in multiple different frequencies. The sixth instrument is the LACP, or the Low Energy Charged Particle subsystem. System. The LACP looks for different particles of a higher energy than the Plasma Science instrument, which is one of the instruments we'll get onto later on the Voyager. The LACP collaborates its findings with the CRS to make the LACP simpler. You can think of it as a piece of wood with particles of interest, being the ones that it's observing, being bullets. The faster the bullets move, the deeper they'll penetrate the wood. That's basic physics. The faster you move, the more power you have. This can then be reverse engineered to tell us the speed of these bullets. So basically, it detects the speed of the particles that it is meeting by telling how far they can penetrate it. The amount of bullets in this wood over a specific time can also tell you how many bullets there are in a space by just looking at how many there are. This will also be able to tell us the different number of particles in a different location, in separate locations of space. The LACP also has 2 subsystems. These are a lower energy particle telescope known as the LEPT and a lower energy magnetospheric particle analyzer known as LEMPA. The 7th instrument is the MAG, or magnetometer. The MAG's primary job is to measure the magnetic field around the Sun along with its changes. This will then be used to determine the magnetic fields of the other planets and, if they have one, how it interacts with their planet's moons. The 8th instrument is the optical calibration target, which is basically just a flat rectangle that's comprised of multiple colors and brightnesses, which is then fixed to the probe so that various instruments can point to their targets. It just helps them calibrate their sensors and everything. The 9th instrument is the PPS, or photopolarimeter system. The PPS is a 0.2 meter, that is a fifth of a meter, telescope fitted with various filters and lenses to look at stuff differently. That is what filters and lenses do. The PPS is designed to determine the physical particulate matter in the atmosphere of the planets that the probes traveled to, along with Saturn's rings. The PPS will also provide us with information on the texture and probable composition of the natural satellites. The 10th instrument is the PRA and PWS, or Planetary Radio Astronomy System and Plasma Wave Subsystem. They're both subsystems. The PRA and PWS share 2 long antennas, which are used to look for plasma on separate radio frequencies. The 11th instrument is the PLS, or Plasma Science System. The PLS is used to measure low-energy ions and electrons that compose a large amount of plasma. The PLS used 3 plasma detectors pointed in the direction of Earth to observe the flow of wind, along with a 4th antenna pointed in a separate direction, which is used to observe planetary magnetospheres. I'm not entirely sure how to pronounce that word. It could also be magnetospheres. I don't know. I'm pretty sure I just said the same thing twice as well. The 12th instrument is the RTG, or radioisotope thermoelectric generators. The RTG system is the income of energy for this mission. The RTG is an array of many different containers of radioactive isotopes in a decaying state. These instruments convert the waves and particles being excreted by the decaying isotopes into usable energy, which the probe then uses to power itself. It's much more effective than solar energy, especially seeing as it's going beyond our solar system, because the further away from the sun, the harder it is to actually get the electrons and whatever solar panels use to create energy. That's why solar panels on Mars aren't going to be very effective, and instead we're probably going to end up using fossil fuels just like we do here on Earth, because it's so much more easy. Otherwise, we could of course use nuclear, but that's not what we're talking about today. The 13th and final system is the UVS, or ultraviolet spectrometer system. The UVS is used to determine when certain atoms are present in the UVS's location. The UVS looks for specific colors of UV light that specific types of atoms excrete. Using this, scientists can then tell which atoms are where and why, and then somehow figure out why they are there. The final thing about the Voyager mission, which is a very interesting part, probably the most interesting part, apart from the fact that they're the first man-made objects to leave the solar system, is the Golden Records. The Golden Records are 2 separate gold records that were placed on the Voyager probes. If you will listen to the records, you would hear different sounds relating to humanity and their achievements. Such as like a tiger's roar, or the wind, or the sea. I'm not actually sure, I haven't listened to it, but I believe there is a YouTube video that is just the Golden Record. The plan for these records was that they would be found by aliens outside our solar system, and they would then somehow listen to these achievements. The reason that I am skeptical about this working isn't because I don't think aliens exist, though the possibilities of them somehow managing to capture a probe that's moving at 17 kilometers or 11 miles a second through space is highly unlikely. I really think that the reason it wouldn't work is because how are they going to have a record player? You can't listen to a record unless you have a record player. If they had a record player on board and some way of communicating instructions to the aliens, then yeah, sure, it could work, but unless the aliens have their own record player and they recognize the Golden Record as a record, it just wouldn't work. Because there's no built-in record player, because record players are pretty big and that would be pretty annoying. And the next problem is the fact that they might not even be able to hear. Humans, we can hear, because that's the way we communicate, but I don't think ants can hear. I don't actually know, but I'm pretty sure they can't hear. They communicate using their antennas. And even so, mammals are also the only animals that actually have a language. Like an audible language. They might not even have a language or a way of communicating. They might use sign language, and this is just audio, so they just think that if they were somehow able to create a record player that is just spinning and it just looks cool. And in conclusion, the Voyager mission was a large and highly complicated mission carrying a precious payload, which is both the scientific instruments that are giving us lots of science about our outer planets and outside our solar system, along with the Golden Record. But it did still have its flaws, being the Golden Record is basically useless unless you're humans. A meteorite. What's that? If you listen to any amount of media, such as TV or movies, you've probably heard phrases such as meteorites, comets, shooting stars, asteroids, but not fully known what they are. All you really know is they're balls of rock. On this section of What's That, we will be answering the question of what is the difference between all of these common rocky debris of space. The first one is a comet. A comet is a body of any physical object in space, such as ice or dust, that is up to several miles or kilometers in diameter and orbiting the sun. Comets' debris is also the cause of meteorites, and Saturn's rings are all comets. They're just balls of ice and dust and rock captured in Saturn's large gravitational pull. Now, a meteoroid is a small rocky or metal object that came off of an asteroid or a comet. The size of these it's a very large wingspan. It can be between a grain of sand, something that's pretty hard to see with the human eye, or that of a boulder. A massive boulder. We all know boulders are big. I mean, they can be pretty small, but on average, they're like all gigantic. The next one is a meteor. Now, a meteor is just a meteoroid that has been able to reach the Earth's atmosphere and then burn up in the Earth's atmosphere because it's so hot. A meteor and a shooting star are actually the same thing. A meteor is a meteoroid burning up in the Earth's atmosphere, and a shooting star is a meteoroid burning up in the Earth's atmosphere. Shooting stars is just a much nicer name for it. So, the whole wishing on shooting stars is just like zodiac signs. It's basically just wishing on something that isn't going to come true. The sun can't determine your personality, and a ball of rock burning up in the Earth's atmosphere won't make your wishes come true. A meteorite is a meteor that managed to reach the surface of the Earth rather than just burning up in our atmosphere. Now, these can usually cause large explosions, but usually they actually explode in mid-air and become lots of smaller meteorites, which then cause a much larger shower of destruction. If it were just to come down as one giant ball, there is the chance that would create large amounts of destruction, but unless it burns up, which it would have to be really big not to, it's really going to be most likely harmless. Because, if it explodes, it has a much larger array of damage. An asteroid is an object that is larger than a meteoroid that still orbits the sun and is made of rock or metal. That's all of the space debris that I found and was actually interested in. And if you have any that you'd like me to cover, just send them to me and I will. And in conclusion, these objects of space debris are basically the same, just with different sizes and with different sizes of rock, metal, different possible compositions, and different levels that they reached in the Earth's atmosphere. I hope you all enjoyed this episode of Over the Moon. If you did, hit like or subscribe. And if you have any questions for What's That section or any topic ideas, please tell me through a comment or an email. It's very hard for me to come up with ideas, so it would be very useful if you gave me some of yours. And if you did enjoy this episode, if you are subscribed, you will get a notification when I hopefully upload next week. We'll see you next week, hopefully on time this time. Bye.